All, all right, so let's start. Okay, so this is the part 2 for problem solving of chapter 19. Okay, so let's start from question number 7. Okay, so here we are given a circuit and we have to calculate I1, I2, and I3. Okay, so this kind of circuit, to solve this kind of circuit, we need Kirchhoff's laws. Okay, and as you know that we have two rule, one is junction rule, another is loop rule. And as we have three unknown here, we need basically three equations. Okay, so first let's try to write down the junction rule for junction A. Okay, so you are free to write any three equations. Three unknown means you need three equations. Okay, it doesn't need to be the same as mine. Okay, there are many way to solve this. Okay, and this is algebra heavy problem. Okay, so you need to understand some mathematical or algebraical manipulation. Okay, so for the junction rule, as I3 is entering A and I1 and I2 are leaving A. So the junction rule tells us this. Okay. And then we can write two loop rules. Okay. So one for the upper loop, this loop, and one for this loop. Okay. So try one by one. Okay. Not to confuse. Okay. So for the top loop, I'm going in this direction. Okay. I'm going in this direction starting from D. From this point I go in this direction. Okay, so the equation will be something like this. So 45 volt, because I'm going from negative to positive, so that's positive sign. Okay, from the negative terminal to the positive terminal, that's why the sign for 45 volt will be positive. Okay, and then because my direction of traveling and the current I3 is the same for the internal resistance 1 ohmega. Okay, so I will have a negative sign here for the voltage drop across the internal resistance. Okay, the same thing for 40 ohmega. Okay, negative sign because I3, the direction of I3 and direction of my traveling is the same, so negative sign. And the same thing for 30 ohmega, but through 30 ohmega the current I1 is going, so I1 30 ohmega, and that is equal to 0. Okay, all right. Now for the lower loop, okay, so lower loop is this. For lower loop I start from this position E and I go in this direction. Okay, so I can write, so first one is I2. Okay, actually I2 1 ohmega. Okay, so here you see I'm going in this direction, the current is in this direction, so that's why because they're opposite, so that's why I have a positive sign. But for battery I will have a negative sign because my direction is from the positive terminal to the negative terminal, which is negative. And then for 40 ohmega it will be positive, I3 40 ohmega. Okay, and then again positive for the internal resistance. Okay, and negative for 45 volt because my direction of traveling is from positive terminal to the negative terminal. And then one thing is this one, so if my direction is this and here the current I2 is flowing in this direction. Okay, so again it is positive because my direction and the direction of currents are opposite, so I2 20 ohmega. Okay, all right. So these are the three equations. Okay. Now, only thing you have to do is manipulating. Doing some algebra. Okay, manipulating these three equations. Okay. So let's try. So first, let's add this equation and this equation. Okay, so let's see when we add these two equations. So many things will be cancelled out. Okay, so when we add them together, you can see that 45 volt here and 45 volt here cancel out. Okay, because they are positive and negative. So let me okay, so 45 volt, 45 volt cancel out. I3 1 omega, I3 1 omega, I3 40, I3 40 cancel out. Okay, so what we are left with is I2 1 omega and then minus 80 volt plus I2 20 omega and then minus I1 30 omega. Okay, so what we have here, if I write just the number, not the symbol, then it will be something like this: I2 minus 80 minus okay, plus 20 I2 minus 30 I1, that is equal to 0, right? So 21 I2 minus 80 minus 30 I1, that is equal to 0. Okay, so if I solve it for I2, okay, I get something like this. So I2 will be 80 plus 30 I1 over 21. Okay, all right. Now still not I mean, here you see that we have two unknown, I2 and I1. So this equation is not too useful yet. Okay, so now to make it useful, let's use the upper loop again. Okay, so upper loop equation was this one, 45 volt. Okay, so I'm not writing the unit. So 45 volt and then I3 times 1 omega, so it is just I3, and then 40 I3 times 40 omega, so 40 I3. Okay, and then I1 30 omega, so that is 30 I1, that is equal to 0. So this is the upper loop equation. Okay, now if I simplify it, I can write it something like this. Okay, and this time let me solve it for I3. Okay, so if I write it for I3, I can write something like this: 41 I3 in the other side. In that side it will be 45 minus 30 I1. So I3 is just this. Okay, all right. Now, so far we basically deal with the two loop equations. Okay, now let's substitute the expression for I2. Okay, okay. So yeah, so let's substitute I2 and I3 into the equation, into the junction equation. Okay, so you know the junction equation was something like this. Um, let me, okay, junction equation was something like this: I3 equal to I1 plus I2. Okay, so I3 is something like this: 45 minus 30 I1. Okay, 41, and then that is equal to I1, and I2 was 80 plus 30I1, okay, 21. Okay, so let's simplify this again. Okay, so it will be 1.1 minus 0.73I1, and then I1, and it is 3.8 plus 1.4I1. Okay, so now you see that the only unknown in this equation is I1. So if I substitute, if I solve it for I1, okay, I will get something like this. So here I have 1.1. If I bring it in this side, that will be 3.8. So I1, 1.4 I1, and then 0.73 I1. So this gives us minus 2.7, and on the other side I have 3.1 I1. So I1 is basically minus 2.7 divided by 3.1. Okay, and that is equal to negative 0.87 amp. Okay, all right. Now you can just substitute this value here in this equation and in this equation, and you will get I2 and I3. Okay, so if you do that, you will get I2 equal to 2.6 amp, and I3 will be equal to 1.7 amp. Okay, and this negative sign here tells us that the direction we are given here is for I1, it's not correct. Okay, so I1 will be basically in this direction with magnitude that is equal to 0.87. Okay, so this is little bit complicated problem. Okay, although I'm not going to set this kind of problem in exam, but there are some problem in the homework, so make sure you understand this kind of problem. Okay, or at least you should understand how to write a loop rule. Okay, that must you understand, and how to manipulate algebra. Okay, all right. All right, the next equation, next question is about capacitor. Okay, so here we are given a capacitor circuit that is connected with a voltage, and um, and here basically it is a combination of series and parallel capacitance. Here we have to determine what is the equivalent capacitance. Okay, so here you see that C2 and C3 are connected in parallel, right? So the equivalent capacitance for C2 and C3 will be just C2 plus C3. Okay, and because the value of C2 and C3 are same, we can write it 2C. Okay, now the circuit is now something like this. Okay, so here is C23 and here is C1, and here is the voltage. So C23 is connected in series with C1, so that equivalent capacitance will be something like this: 1 over 2C, C23 plus 1 over C1. Okay, so this is 1 over 2C and this is 1 over C. Okay, so when we solve it, we can see that it is basically 2C1 plus 2 over 2C. So it is basically 3 over 2C. Okay, so C equivalent is just reciprocal of this or the reverse of this. So 2C over 3. Okay, all right. Next one. Okay, so now we have to use the same circuit as of question 8, but this time we have to determine the charge on each capacitor. Okay, and assume that the capacitance is 3 microfarad and voltage is 4 volt. Okay, so remember that Q equal to CV. Okay, so that equation we may need. And also, because now we are given the magnitude of the capacitance, so we can determine Ceq is this 2 times 3 microfarad divided by 3, so that is 2 mic uh, that is, yeah, 2 microfarad. Okay, remember that micro means 10 to the power minus 6. Okay, all right, so then Q equal to Ceq V tells us that the total charge is 2 microfarad times V. V is 4 volt. Okay, so it says that the total Q is 8 microcoulomb, right? Okay, and this tells us that here and here the charge will be 8 microcoulomb, right? So you know that when the capacitors are connected in series, the same charge, I mean, because of the same current similar in the resistor, the same charge will be charged the series capacitors. So C1 and C2, C23 will be charged with these. Okay, so although we are not interested on C23 but their components, but here this gives us a very important information about C1. So the charge on C1 will be 8 microcoulomb. Okay, and the 8 microcoulomb, the another 8 microcoulomb, I mean the C23, the 8 microcoulomb on C23 will divided into two, C2 and C3. Okay, so 8 microcoulomb will be divided into C2 and C3. Okay, and here because the C2 value is 3 microfarad and this value is also 3 microfarad. Okay, so 8 microcoulomb will be equally divided into this and this, right? Because they are the same, the capacitance magnitude is the same for C2 and C3. Okay, so half will go here and half will go here. Okay, so what it means Q2 will be 4 microcoulomb and Q3 will be 4 microcoulomb. Okay, all right. So that's one thing. And then the last part tells us that the voltage across each capacitance. So we have to also calculate the voltage. Okay. All right. Now V equal to Q over C. Okay. This equation basically gives you all the voltages across all capacitance. Okay, so V1 will be Q1 over C1. So Q1 was 8 microcoulomb, right? C1 was 3 microfarad, right? So this gives us 2.7 volt. Okay, similarly V2 is Q2 C2. Q2 is 4 microcoulomb and C2 is also 3 microfarad. So it is basically 1.3 volt, and V3 will be similarly Q3 over C3, and it is also 4 microcoulomb over 3 microfarad. So the value is again 1.3 volt. Okay. All right. The last one, oh no, not last one, 10 and 11. Okay, so 10. Okay, so this is about RC circuit. Okay, so the charging of an RC circuit. So what we are given here, we are given the capacitance, we are given the resistance. Okay, and we are given that R and C are connected with 12-volt battery. So the first one we have to calculate is the time constant. Okay, so time constant, if you remember, is equal to RC. So R is given, kilo means 10 to the power 3, and capacitance is also given, and micro means 10 to the power minus 6. Okay, so when you multiply this together, you get time. Okay, and what we get here is 0.006 second. So the time constant for this RC circuit is 0.006 second. So we are done for the first one. The second one is the maximum charge of the capacitor could occur. So the maximum charge, if you remember, is Q0, and that is equal to C and then the EMF. Okay, C here is 0.30 times 10 to the power minus 6 farad, and the EMF is 12 volt, battery EMF. And that tells you the charge, maximum charge this capacitor can have, that is equal to this, or 3.6 microcoulomb. Okay, so this is A, this is B. C tells us that how long, okay, it takes for the charge to reach 99% of this value. Okay, so basically I want to know what is the time. Okay, so we need this equation, 1 minus e to the power minus t over RC. 99% of Q0. Okay, 1 minus t, RC means tau. So let me write just tau. Okay, so you see Q0 cancel out, and 99% means 0.99, right? 1 minus e to the power minus t over tau. So let me take e in this side, and it shows me that this is equal to just 0.01. Now if I take log, natural log on the both side, I get this t over tau here, and log, natural log of 0.01, which is equal to negative 4.61. So this negative cancel out. Okay, so t, the time, is equal to then times tau, and tau is equal to 0.006 second, which means 0.028 second. So the time it requires is 0.028 second. All right, and then the maximum current. Maximum current, if you remember, was this. Okay, so 12 volt, and R is 20 times 10 to the power 3 omega. So which means the current, maximum current in this circuit is 0.0006 ampere. Okay, all right. The last problem is about discharging. Okay, again it is RC circuit. Okay, now the capacitor is this one, resistor is this one. Okay, and it tells us that determine time when the voltage falls to 10% of its original or the maximum value, right? When it charges, its voltage is V0, but it tells us that how long it takes um, to have the voltage that is equal to 10% of V0. Okay, so for discharging, the voltage is something like this: V equal to V0 e to the power minus t over RC. Okay, so it tells us 10% of, find the time when the voltage is 10% of V0. Okay, so V0 cancel out. 10% means 1, 0. Okay, now if I take the log, natural log on both sides, I get, okay, and the natural log of this is equal to negative 2.30, and this. Okay, so this and this cancel out. So then T is equal to 2.30 times RC. So 2.30 R here is 120 ohm and C is 35 microfarad. Micro means 10 to the power minus 6 farad. So if you multiply all them together, you should get something like this. Okay, so the time it requires is 0.0097 second. All right, so that's it for this chapter.